Hello. We have seen that the concept of energy occurs in all areas of physics. We started with mechanics. We discussed energy in application to heat and electricity. And now I want to talk about energy as used in our society. I want to trace the sources of energy. I want to review what sources of energy are available to us for our consumption and what are the physics aspects of environmental impacts of these different sources. So the most obvious nearby gigantic source of energy is sun, where matter is heated to 1,000,000 degrees inside by gravitational contraction, and thermonuclear reactions take place in this interior. These thermonuclear reactions produce all that heat, which eventually reaches the surface and gets radiated away from the surface called photosphere, for reasons that that's where the photons decouple from matter. And we can see this as a surface, but it's not a solid surface. It's just a surface from which the photons can travel freely. These photons reach Earth and heat up the surface of the Earth. The Earth, of course, is surrounded by a thin layer of air, the atmosphere. Sunlight enters the atmosphere and heats up the surface of the Earth, and the warm surface of the Earth also radiates away some energy. The energy that is coming from the sun is essentially determined by solar power, by the output of the sun and the distance between sun and the Earth, which doesn't vary significantly over the year. However, the energy that is radiated away from Earth depends on the temperature of the surface. And so the energy in is more or less constant, and the energy out is proportionate to the temperature of the surface to the fourth power. By energy conservation, these two quantities must be equal, in equilibrium, and that tells us that the Earth's temperature is adjusted automatically to compensate for this difference in the absorbed and radiated energy. But of course, the energy radiated away has to pass through this sliver of the atmosphere, and some of it can get caught in the atmosphere because the energy that comes in is normal visible light, but most of the energy radiated away from the Earth is infrared light. And the transparency of air to visible light and infrared light is not the same. So this will bring us to a discussion of possible environmental impact, because the transparency of atmosphere to infrared light is determined by concentrations of various gases that have asymmetric molecules. Water is very important. Water vapor in the atmosphere is probably the main controlling factor of how transparent the atmosphere is to infrared radiation leaving the Earth's surface. The next important contributor is CO2, carbon dioxide. And then there are other asymmetric molecules, such as methane and other gases, that determine the transparency of the atmosphere. If the amount of some of these gases is changed, the balance between the energy going in and the energy going out can change, and that will result in the change of global temperature. How exactly that change occurs depends on very great variety of factors and requires detailed scientific investigation. But it is clear that if we increase the concentration of carbon dioxide or the concentration of methane, the atmosphere traps more of the infrared radiation and makes it more difficult for the energy to escape the Earth's surface. So to compensate, the surface has to raise its temperature. Of course, there are many other compensating factors that have to be taken into account. The cloud cover may change, the albedo of the Earth's surface may be different at different historical epochs. So all of these factors have to be taken into account in considerations of climate change as a result of these chemical changes. But this solar power, of course, is a very important source of energy for everything that exists on Earth. And the solar power is the reason trees can grow. It's the reason the wind blows, and waves, or at least some waves in the ocean. In particular, this piece of wood contains a lot of carbon. Where did it come from? Where does carbon come from? Well, it comes from trees, right? This is a piece of wood, it comes from a tree. A tree collects most of its weight, not from the ground, not from water, but from air. It absorbs carbon dioxide from air, and it uses solar energy to break this molecule apart, separate out carbon, and put it into the tree trunk to make it grow. So all that energy actually gets stored in the carbon that the tree accumulates over its life, and then wood, on the geological time scales, can change into oil and natural gas, which are called fossil fuels, because that's the fuels that humans dig out from underground and burn to produce energy. Ultimately, the energy that we use when we burn fossil fuels does come from the sun. But these sources of energy are called non-renewable, because it takes an enormous amount of time, geologically long times, to replenish the amounts of wood, oil, natural gas, and coal. So this, it's not practical for people to wait for these sources to be renewed. So we call them non-renewable energy resources. So the reason for the name is a little bit of a misnomer. They are renewable, but we use them up much faster than any natural processes that can renew them. On the other hand, solar power, wind, tides, and waves can be used for energy production without depleting these resources. So these are renewable energy resources. These energy resources are used, but unfortunately, only a few % of the total energy consumption in modern society comes from solar power. And even smaller fraction comes from wind, tides, and waves. One reason why non-renewable sources of energy are so popular is because they can carry a lot of energy for a small weight. Oil, in particular, can carry as much as 10 kilowatt hour per kilogram. And it is very convenient to put that much energy in the tank of a car or an airplane where weight plays a significant role, because oil is comparable to high explosives in the amount of energy it can carry per kilogram. The bad thing about using non-renewable energy from fossil fuels is twofold. First, one can exhaust these resources in a finite time. And second, when we use chemical reactions to oxidize carbon in wood, oil, natural gas, or coal, the side product is carbon dioxide, which can affect the transparency of the atmosphere and change the energy balance, hence changing the global temperature. Of course, these are not the only sources available to humankind as sources of energy. In addition to these sources that I listed here, there is a possibility of using nuclear power and thermonuclear power, which is actually the same type of reactions that power the sun. These are not renewable resources. One can exhaust the supply of uranium ore in a finite time. But this amount of ore available is actually very, very large. With thermonuclear reactions, the fuel is in the ocean. It would utilize heavy water, which is part of normal water, and would, again, be the kind of a resource that, although technically is finite, would last for a long time. While thermonuclear energy is far in the future, nuclear power is available today and can be used today without producing any of these greenhouse gases. Unfortunately, nuclear power entails some other set of issues related to the environment. Nuclear fuel, after being processed in a nuclear plant, remains radioactive, and one has to decide what to do with the nuclear waste. One way to handle nuclear waste is to store it. But if one needs to store nuclear waste for a very, very long period of time, one may worry about the leakages, about the damage to the storage that can occur as a result of an earthquake. And all these issues become exceedingly important if one has to store nuclear waste containing long-lived isotopes. There is a way to speed up the time scale on which the nuclear waste has to be stored by putting nuclear waste in the way of a very high power beam of charged particles in a collider. Such beam can convert long-lived isotopes into short-lived isotopes, and then the storage time becomes shorter. There are many other ideas that people have about making nuclear power safer and environmentally friendly. And with more research, one undoubtedly will come up with even safer ways to handle this source of power.